Hello everyone, welcome to my channel. Let us do self-study. Today we will be discussing polynomials. Polynomials use the form of algebraic expressions, and algebra is the use of symbols for real number. So we will start with some basics like a plus a is 2a and a multiplied by a is a to the power 2, a square. Likewise, 3 plus 3 is 2 times of 3 and 3 multiplied to 3 is 3 square. So this is very simple thing, but let us not get confused with this. So like a added 5 times is 5a and a multiplied 5 times is a to the power 5. Likewise, if you are told to add a plus b, then a plus b is only a plus b. We cannot add it further. And a multiplied by b, we can write it in the form of ab. So this is the basic we start with. And algebra is the use of symbol for real numbers.
Okay, so variables are the symbols that can take any real value. In any algebraic expressions, we use the symbol for variables and we use the symbols for constant also. So if in an algebraic expression a symbol is a variable, then it will take any real value. And if we are using the symbol for a constant, so that constant will be the same. It will not change for that particular situation. In a different situation, that constant will also change. So that constant is also use of symbol for a real number. So in algebraic expression, a symbol can be used for variable and a symbol can be used for constant as well. Generally, we denote constants with a, b, c and variables with x, y, z. So what is the use of polynomials and what is the use of algebraic expression? Like, let us suppose the price of one pen is x. The price of 10 pen is 10x. We still don't know the price of pen. We assume that the price of pen is x and we can calculate the price of 10 pen, that is 10x. And if we have like price of one book is y, then we have to buy 30 books, so the price of 30 books is 30y. And we have to told that we have to buy 10 pen and 30 books, then we can say that the money which we will be needing is 10x plus 30y. So this becomes an algebraic expression in two variables, x and y. X is the price of pen and y is the price of book. So likewise, these are the uses of polynomials. These are the uses of the algebraic expressions. And when we know the price of pen, we can put that value and find the value. Like perimeter of a square. If we have to find the perimeter of a square, if we know the side, each side is 3, then it's 4 times 3. And if we don't know the side of each square, we assume it is x, then perimeter is 4x. And area is x times x, that is x to the power 2, x square. Polynomials in one variable. So if the variable is 1, only x or only y or only z, then those polynomials are in polynomials in one variable. And polynomials can have multiple terms. So basically terms are the number of items in the expression. Like x square plus 2x, the next terms are 2. 3y square plus 5y plus 7, the terms are 3. So this is called terms of a polynomial. So for minus x cube plus 4x square plus 7x minus 2, there is 4 terms in this expression. Minus x cube, 4x square, 7x minus 2. So these are the terms. Right. So later we will learn in a quadratic expression what can be the maximum number of terms. In a linear polynomial, what can be the maximum number of terms. So later we will learn that. So this term will be used later. And coefficient of each term. So there are two terms in x square plus 2x. And the first term is x square. Okay. And the coefficient of x square is 1. So it is 1 multiplied by x square. So the unknown is x square and Any constant multiplied to that is the coefficient. Like 2x, the coefficient is 2. The coefficient of minus x cube is minus 1. Coefficient of 4x square is 4. Coefficient of 7x is 7. Likewise. So these are called coefficient of x term. Like coefficient of minus 2, what is the coefficient of minus 2 in this expression? Minus x cube plus 4x square plus 7x minus 2. The coefficient of minus 2 is minus 2. Why? Because minus 2 is also one of the term where x to the power is 0. X to the power 0 is 1. So the coefficient of minus 2 x to the power 0 is minus 2. So these are called, we have learned two things, terms and coefficient. Next is exponent of a variable. The exponent of x cube is 3. Exponent of x square is 2. So exponent, we know what is called exponent. One important point to note is for any polynomial the exponent will be whole number. If the exponent is 1 by 2, if exponent is negative, if exponent is not a whole number, then those expressions are not a polynomial. Those are a simple algebraic expression, but those algebraic expressions are not called a polynomial. For an algebraic expression to be a polynomial, the exponent of all the terms has to be whole number. So x plus 1 by x, the exponent of x is minus 1. So this algebraic expression is not a polynomial. Like root x plus 3, the exponent of x is 1 by 2. So this expression is also not a polynomial. So so we have started with the definition of a polynomial. So the main definition of a polynomial is polynomial is an algebraic expression where exponents of all the terms are a whole number. So like the constant 2, minus 5, 7, 9, 3, 2, these all numbers are these polynomials. If we say like px is equal to 2, so is this an polynomial? So yes, px is equal to 2 is also a polynomial. Px is equal to minus 5 is also a polynomial. Why? Because we can write 2 as 2 into x to the power 0. So here the exponent is whole number. The exponent of x is whole number. So px is a polynomial where the value does not change based on the value of x. But still here the exponent is whole number, so this is a polynomial. And this polynomial is called constant polynomial. If the variable is x, we can write polynomial by px or qx or rx. If this variable polynomial is one variable, then it will be px. If it is in a polynomial in two variables, then we write pxy. Okay, so we are discussing polynomial in one variable. So px is 2x square plus 5x minus 3x. Let us suppose 3x to the power 0. Qx and ry, right? So ry is y cube plus y plus 1. These are some of the definitions of polynomial. These are some of the polynomials we are discussing. So based on term, we call polynomial as monomial, binomial, trinomial, and you can go on like 4 terms, 5 terms, 6 terms, right? For only 3 terms, we have definition, a specific term for that. We call it monomial if there is only one term. We call it binomial when there is 2 terms. We call it trinomial when there is 3 terms. So this is based on number of terms. It has nothing to do with the degree and anything. It is only terms like 5x cube is also monomial and 2x is also a monomial, and even 2 is a monomial. Like x square minus x is a binomial and x plus 1 is a binomial. So these are just naming the polynomial. The two term we call it binomial. And degree of a polynomial. Degree of polynomial is defined by the highest exponent of any term in a polynomial. So like 3x to the power 7 minus 4x 6x to the power 6 plus x plus 9. The degree of the polynomial is 7 because the maximum exponent of this expression, this polynomial, is 7. So degree of a polynomial is defined by the maximum exponent of the expression. Okay, so one question, are these polynomials? 2, 6, minus 5. Yes, because it can be written as 2 into x to the power 0 and degree of constant polynomial is 0. So these polynomials are called constant polynomial because the value of these polynomials will not change based on the value of x or y or those variables. So these are called constant polynomials. Even 0 is a constant polynomial and this is specifically called zero polynomial. The constant polynomial 0 is called zero polynomial. So there is a separate term for 0, that is zero polynomial, but it is also a constant polynomial. So 0 is a constant polynomial. Constant polynomial, why? Because these are constant. That's simple. We do not have to be confused with the expressions, naming, right? These are all definitions of polynomial. Are these polynomials x plus 1 by x? No, because the power of x is minus 1. Cube root of y plus y square. This is also not a polynomial. This is an algebraic expression, but this algebraic expression is not a polynomial. So the power of y is 1 by 3. That is not a whole number. So if exponent is not a whole number, those expressions are not polynomial. Now comes with the degree. Degree of each polynomial is 1. Degree means the maximum exponent of the expression. So the maximum exponents of the variable in all these terms is 1. Like 4x, the maximum is 1, 2y, root 2t plus root 2. We have to understand this. The number, those are real numbers. We do not have to see the exponent of that. We have to only see the exponent of the variable. So in a polynomial, we have to see the degree of like the exponent of the variable. So a polynomial of degree 1 is called linear polynomial. So we have linear polynomial where the degree of the polynomial is 1. So the degree of polynomial is 1, then it is called linear polynomial. Can you write linear polynomial with 3 terms? Can you write its linear polynomial with 3 terms? Like 4x plus 5 plus root 2. But 5 plus root 2 is the same constant. We can combine those as a one constant. So can you write linear polynomial with 3 terms like 3x plus pi plus 3? Is it 3 terms? This is not 3 terms because pi plus 3 is a constant. So we cannot write with three terms. All the constant will come in as a one term only. So general form of a linear polynomial is fx is equal to ax plus b. Ax means a is some constant and x is the variable and b is some constant. If we can try to write it with 3 terms, we cannot write that because all the constant will come in one expression, that is b. Okay, so we have learned linear polynomial. Now we learn quadratic polynomial. So quadratic polynomial degree is 2. And maximum number of terms in a quadratic polynomial can be 3. Right? The general form will be ax square plus bx plus c. Cubic polynomial. The cubic polynomial degree will be 3, and the general expression will be ax cube plus bx square plus cx plus d. So a, b, c, d are constants and x is the variable. So this is what we were talking about. D, a, b, c, d are also symbol, but in the algebra, we generally didn't use them to represent constant. So a, b, c, d are also like symbols, but these are a constant of this expression. So d is representing constant. C is also one constant multiplied with x. So ax cube plus bx square plus cx plus d is a cubic polynomial. Why? Because the maximum exponent is x3. So like gx, here x cube. So this is also a form of ax cube plus bx square plus cx plus d. Here a is 1, b is 0, c is 0, d is 0. So if we use a as 1 and b 0, c 0 and d 0, it will become x cube. So for like rx 4x cube. So this here a is 4 and b c d all are 0. Cubic polynomial can have maximum 4 terms. Polynomial in one variable and degree n. So this is the general expression. We have learned linear polynomial, quadratic polynomial and cubic polynomial. And when we have a polynomial of one variable and degree n, so this is the general expression. You replace n with 1, 2, 3, and you get to different degree of polynomial. So with degree n we have a n. So when we write n in the subscript, this is only denoting one of the symbol. A n is not nothing but a symbol a n. You have to just read it as that. A n minus 1 is one of the constant. There is no exponent here. We must understand this. A n minus 1, when we write n minus 1 on the subscript, then this is a constant. We are generally using it as a constant. Like instead of writing b, we are writing a n minus 1. So this is just like that. A n x to the power n. So here n is the exponent of x. Right? Exponent of x is n. So if an is not 0, then the degree of this polynomial is n, because the maximum exponent is n. Suppose an is 0, so the first expression will become 0. So the degree of this polynomial will not be n, right? So this is the important, that an has not to be 0. Let us write polynomial of degree 5. So we can write that using that form, that expression. What is called constant and what is called variable? So we discussed in this. The constant is a, b, c, d, or a5, a4, a3, and x is the variable. Let us write some common polynomial. Like area of a square is fx is equal to x square. Area of 4 numbers of such a square is 4x square. Right? That we discussed earlier also. And an area of a square with each side as 0 is 0. An area of a square with each side as 1 is 1. If right, an area of a square with each side as 9 is 9 into 9, that is 81. Right? An area of a square with each side as root 2, the root 2 square, that is 2. And area of 4 square with each side as 9 is 4 times 9 square, that is 324. So area of 4 square, the expression is gx. Gx is equal to 4x square. So this is the example to understand polynomial and use of polynomial. We discussed polynomials in one variable, and polynomial in three variables will be x square plus y square plus x plus xyz. Here the unknowns are 3, x, y and z. So this is the polynomial in 3 variable. So we will do the exercise 2.1. So before we do the exercise, I will suggest to, you to do that yourself, and then you can continue the video. And in the video, at any point of time, if you do not understand anything, just pause the video, go to your NCERT book, read it, and read it one time, two times, three times. Read till you do understand it completely. You can refer to different sources. If you can understand in this video, that's fine. If you cannot understand, just pause the video, go to your book. So for this exercise, first you do it and then come back again. Which of the following expressions are polynomials in one variable? So which of the following expressions are polynomial in one variable? So the variable in this, the first expression is only x, 4x square minus 3x plus 7. So variable is only x. So this is the variable is 1, degree is 2, and terms are 3. So this is the first expression is polynomial is one variable. So answer is the first. So the first one is the polynomial is one variable, right? Because variable is only one, so this is polynomial is one variable. Y square plus root 2, the variable is only y, so this is also one polynomial in one variable. 3 root t plus t root 2, the variable is only one, but exponent is not a whole number. So this expression itself is not a polynomial, right? So the question is, which are polynomial in one variable? So if it is not a polynomial, so the question is closed. So this is not a polynomial, right? This is in one variable. The algebraic expression is in one variable, but this expression itself is not a polynomial. So this is not a polynomial in one variable. 2y plus 2y, here also the same thing. This is not a polynomial because the exponent is not a whole number. Here the variables are three, x, y, and t. There are three variables, so this is also not a polynomial in one variable. Write the coefficient of x square. 2 plus x square plus x. We can write it as x square plus x plus 2, the same thing. And ax square plus bx plus c. That is the general expression of a quadratic polynomial. So coefficient of x square is 1, right? Coefficient of x square in this expression is minus 1. To understand it, I have written in the form of ax cube plus bx square plus cx plus d. Here a is 1, b is minus 1, c is 0, d is 2. So that is the cubic polynomial, and coefficient of x square is minus 1. You can say it directly from here. Coefficient of x square is minus 1. Coefficient of x square is pi by 2. Here the coefficient of x square is 0 because there is no x square in this expression. Right? So we can write it 0 times x square. So coefficient of x square is 0. Give one example each of binomial of degree 35 and of a monomial of degree 100. So based on number of terms, monomial is polynomial with one term, binomial is with two terms, trinomial is with three terms. So we have to give example of binomial of degree 35, and based on degree of terms, linear, quadratic, cubic, and likewise. So binomial of degree 35 is, these are some of the binomial of degree 35. Binomial means the term has to be not 2, and the degree of the polynomial has to be 35. So y to the power 35 plus y to the power 34. So this is also a binomial of degree 35. So these are three of them, binomial of degree 35. And monomial of degree 100. Monomial means the term has to be only one, single term. So these are the example of monomial of degree 100. We can write pi y to the power 100. This is also a monomial of degree 100. Write the degree of each of the following polynomial. So what is degree? The value of the maximum exponent. So likewise we can say the degree of the first expression is 3, second expression is 2, 5t minus root 7, degree is 1, and this is a constant polynomial, so degree is 0. So we can write 3 as 3 x to the power 0, so degree is 0. Classify the following as linear, quadratic and cubic polynomial. So linear, quadratic and cubic are based on the degree of the polynomial. This is not based on terms, this is based on degree. So degree of the first expression, x square plus x is 2, maximum exponent is 2, so this is quadratic. X minus x cube, degree is 3, so this is cubic polynomial. Y plus y square plus 4, the degree is 2, so this is quadratic polynomial. This is 1 plus x is linear, 3t is linear, r square is quadratic, 7x cube is cubic polynomial. Okay, so we have done with the exercise, and now we will be going with the definition of zeros of a polynomial. So zeros of a polynomial is that value of the variable for which the value of the polynomial is 0. So that is called zero of the polynomial. So we have an polynomial px is equal to 5x cube minus 2x square plus 3x minus 2. So to find the zeros of this polynomial, we will put the different value of x in this expression and try to find out what is the value. So for p is equal to x is equal to 1, p1 is equal to 5 into 1 cube minus 2 into 1 square plus 3 into 1 minus 2, so that is 4. P0 is when you put x is equal to 0, so the P0 is minus 2 and P minus 1 is minus 12. So in this expression we see we have not found the zero of this polynomial, right? We need to find out another numbers, another some iteration, and we may find the zeros of this polynomial. Let us see the another expression, px is equal to x minus 1. So p1 is 1 minus 1, that is 0. So 1 is the zero of this polynomial. 1 is the zero of the polynomial x minus 1. Qx is equal to x minus 2 and q2 is equal to 0. So 2 is the zero of this polynomial. Zero of a polynomial px is number c such that pc is equal to 0. Zero of a polynomial is also called root of the polynomial. Right? Like linear equation in one variable. X minus 1 is 0, so x is equal to 1. Right? So this is also called root of the polynomial. Zero of a polynomial is found by equating the polynomial to 0. Right? So if px is equal to 2x plus 1, find a zero of the polynomial px is equal to 2x plus 1. So what we will do? We will equate 2x plus 1 to 0 and try to find the value of x. So here we got the value of x as minus 1 by 2. So if you put 1 by 2 in this expression will become 0. So 0 of this polynomial is minus 1 by 2. For a general linear polynomial, find 0 of linear polynomial px equals to ax plus b. So this is the general expression for linear polynomial ax plus b, and we will try to find the roots of this equation. So ax plus b is equal to 0, so x is equal to minus b by a. So for x is equal to minus b by a, the value of the polynomial is 0. A linear polynomial has one and only one zero. So for only one value of x, this expression will be 0. One and only one root, we call it. There is only one and only one root of this linear polynomial. We know that, right? But do you know that for the quadratic polynomial we can have two roots? For a cubic polynomial we can have three roots, like three such values for which the expression is 0. So that is not 0 at only one point, that it is 0 at multiple points. Like we can see ax plus b. What is the general graph of ax plus b? this is x and this is y, like ax plus b, y is px. We can write this is, if this is x, this is px. So if it is a linear polynomial, the graph will be like this. If it is a quadratic polynomial, you can try to find out yourself. If it is a quadratic polynomial, what will be the shape of this curve, and if it is a cubic polynomial, what will be the shape of this curve. This is the assignment. You may try yourself by taking one example and plotting it on a graph. Let us see quadratic polynomial. Fx is equal to x square minus 2x. So why it is a quadratic polynomial? Because the degree is 2. The maximum exponent is 2. So this is a quadratic polynomial. We will try to find out the zero of this polynomial. We know the zero of this polynomial is 0 and 2. There is a way to find out, but here we know this. We will put 0. So f0 is 0 and f2 is 2, 0. So polynomial can have more than one zero also. Like I told you, for linear polynomial there is only one value, but for quadratic polynomial there are two values for which this will be zero. Likewise, for cubic polynomial there will be three values, and if you go with a degree n, a polynomial with degree n, there can be n such value, but it is not necessary that all n will exist. So so for now you can just understand that a polynomial can have more than one zero, but it is not necessary that all the polynomials will have some x for which it is zero. Some of the polynomials cannot have any zero, like it never cuts the x-axis. Its value is never zero. So there we can have a polynomial for any value of x, its value is not zero. So that is also possible, and likewise there can be multiple value of x for which the polynomial is zero. So this is also true. So a polynomial can have more than one zero. So when I said this, the polynomial can have more than one zero, I am also telling that a polynomial can have none of the value of x for which it is zero. This is also possible. Find the value of polynomial fx at, so we are with exercise here, so we need to pause and go to the exercise and do it yourself and then come back here. So find the value of polynomial fx is equal to 5x minus 4x square plus 3 at x equals to 0, x equals to 1 minus 1 and x equals to 2. So what we have to do, we have to find the value of polynomial at different value of x. So we will put the value of x as 0 in this expression and find out the value. So this is simple. Find p0, p1 and p2 of the following polynomial. So for all the polynomials we have to put the value as 0 and 1 and 2 for the value of the variable at the place of the variable. So if you need help you can see this. Verify whether the following are zeros of the polynomial indicated against them. So we have to see if x is equal to minus 1 by 3, it becomes 0. We will put the value minus 1 by 3 and check whether it is 0 of the polynomial or not. Here 4 by 5 is not the 0, so this 4 by 5 is not the 0 of the polynomial. So we have been given an expression px is equal to 5x minus pi, and at x is equal to 4 by 5 we have to find the value of this expression. Here px is equal to x square minus 1. So by putting 1 it is 0, p1 is 0 and p minus 1 is also 0. So 1 and minus 1 are zeros of this polynomial. So this is correct. This is the zeros of the polynomial. Here also minus 1 and 2 is zeros of the polynomial because x plus 1 and x minus 2. So first this becomes 0 and next time this becomes 0. So anything multiplied with 0 is 0. Px is equal to x square, x is equals to 0. P0 is 0. So x for x is equal to 0 is the 0 of this polynomial. Likewise, this is the linear equation Lx plus m, linear polynomial only. Find the 0 of the polynomial in each of the following cases. So we have to, here we do not know what is, where for which value of x this polynomial is 0. So px is equal to x plus 5. So we will assume x plus 5 is 0. So x is equals to minus 5. So how this has to become minus 5? Because LHS is equal to RHS. So on the both sides we have subtracted minus 5. So x plus 5 minus 5 equals to 0 minus 5. So x is equal to minus 5. We need to understand this. Why the 5 goes on the right hand side, then it becomes negative. Why it becomes negative? Because we have subtracted 5 from both sides. So on the left side the 5 becomes 0, 5 minus 5 is 0, and on the right side it becomes minus 5. 0 minus 5 is minus 5. Px equals to x minus 5, so we have to find the value for which value of x this is 0. So x minus 5 is 0. So for which value of x this is 0? If you put x equals to 5, then 5 minus 5 is 0. So we found by solving the equation x equals to 5, this polynomial is 0. So we are finding the zeros of all these polynomials. So zeros of these polynomials are found by solving the linear equation. So now we have come with a very important and a simple thing, remainder theorem. So when we read remainder theorem, a big name, and we understand think that it is like very big thing. But yeah, it is important, but it can be very simply proved, right? So if px is divided by x minus a, then remainder is pa, right? So at the first glance, it is looking like how it is happening. Like px is divided by x minus a, then remainder is pa. So let us see how this is happening. Okay. So when px is divided by x minus a, so when we divide something by x, then we can write one is quotient and one is remainder. When in division there is dividend, divisor, and quotient and remainder. You see here, dividend, divisor, quotient, and remainder. We note that dividend equals to divisor into quotient, divisor into quotient plus remainder. This is the general form, right? So if the algebraic polynomial, if the polynomial is px, and we can write it in the form of x minus a into qx, because we are dividing it with x minus a. We are dividing the polynomial with x minus a. So let us suppose the quotient is qx and remainder is rx, right? So because we are dividing it with x minus a, so this in this Rx there will this will be a constant polynomial, because degree of this polynomial has to be less than 1, because if it is more than 1 or equals to 1, then this will be further divided. So we will understand it another way, but I have come just here. So let us suppose if we divide it, then px is equal to x minus a into qx plus r, and if x is equals to a, then PA is equal to R. So this is the proof of the simple proof of the remainder theorem. So if you divide a polynomial by x minus a, then remainder is PA, because if you put the value of a here, you can see the remainder, what it becomes is a minus is 0. So 0 multiplied by quotient is 0. So what is left with only remainder. We will do it again. We will do it the same thing again. We will go back. So this is the expression of remainder theorem. If px is divided by x minus a, then remainder is pa. This is the simple form of the definition, but this is the exact definition. Exact definition is, let px be any polynomial of degree greater than or equal to 1, and let a be any real number. If px is divided by linear polynomial x minus a, then remainder is pa. So in exam, if you have to write the definition of remainder theorem, you have to write it in complete form. That is, let px be any polynomial of degree greater than or equal to 1, and let a be any real number. So polynomial px has to be greater than or equal to 1. Degree has to be greater than or equal to 1. If px is divided by linear polynomial x minus a, then remainder is pa. So let us first understand division of polynomial. How we divide polynomial. So let us divide 3x to the power 4 minus 4x cube minus 3x minus 1 by x minus 1. So this is the process of division. How we divide polynomials. To divide polynomial, what we do is we do make it 0 the first, the highest degree we make it 0. So to make 3x to the power 4 0, we have to multiply x minus 1 with 3x cube. So we have written in the quotient 3x cube, and if you multiply 3x cube with x minus 1, what it becomes, 3x to the power 4 minus 3x cube, right? And we have to subtract the lower expression from the upper one. So the first one you have to change the sign minus, and this is plus. So you have to add these two, minus minus plus, right? So this so you can understand this yourself. So try to do it. So this is how we divide. Here the next term is minus x cube. So to make it 0, we have to multiply it with minus x square. Again, here we have got 4x minus 4x. So to make it 0, we have to multiply it with minus 4. So minus 4 is this, minus 4x plus 4. So it becomes, the remainder becomes minus 5. So we can write this expression as fx is equal to x minus 1 into quotient in plus remainder. What? Divisor into quotient plus remainder, right? And if 1 is equals to, so x minus 1, if x is 1, then 1 minus 1 is 0. So 0 multiplied with whole this expression is 0. So what is left is only remainder. So if fx is divided by x minus a, then remainder is fa. So this is the simple thing, right? Divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. If you remember this formula, then you can understand remainder theorem very simple way. So this is the proof of remainder theorem. Let px be any polynomial with degree greater than equals to 1. Suppose that when px is divided by x minus a, then quotient is qx and the remainder is rx. That is, px equals to x minus a into qx plus rx. Degree of remainder will be less than degree of divisor x minus a. Why? Because if its degree is 1, then we have to further divide it, right? Like in this division we have seen this. Here it is coming x plus 1. So if we cannot say the remainder is x plus 1, we have to further divide it. On this division also we have seen this. This is minus 4x minus 1. The degree is 1 here. So we have to further divide it. We have to divide it till the degree is less than 1. Then only we call it remainder. Otherwise we have to continue dividing. So the degree of the remainder has to be less than 1. Degree of remainder will be less than degree of divisor. So, right? So if it is not less than degree of divisor, we have to continue dividing. So that is the main thing. So because the degree of x minus 1 a is 1, so degree of rx has to be 0. So rx is simply a constant. This is a constant polynomial. So px is equals to x minus a into qx plus r. and for x equals to a, this becomes pa becomes r. So pa is equal to remainder. Hence, if px is divided by x minus a, then remainder is pa. So this is remainder theorem, and the later you will learn factor theorem, and that will say if remainder is 0, so x minus a is a factor. So if pa is 0, so x minus a is a factor. So that is factor theorem, right? X minus a is a factor of px. When it will be a factor of px? When the remainder is 0. When you divide px with x minus a, you will get remainder as 0. Then x minus a is a factor of px, right? So if pa is 0 means if you divide px with x minus a, then remainder is pa, and if remainder pa is 0, so there is no remainder, so x minus a is a factor. So from remainder theorem we get the proof of the factor theorem that we will learn later. We have come with two exercise. So first do the exercise, pause the video and come back again. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1, x minus 1 by 2, x plus pi, 5 plus 2x. So these are the different expressions. These are all linear polynomial with which it has to be divided. So these all are the divisor is all linear, and we have to divide it to this expression px. Okay. So x minus a. So what is the value of a here? X plus 1. The value of a is minus 1. Right, so x minus minus 1 is plus 1, x plus 1. So you have to first find the zeros of this. Let us divide fx with x plus 1. I have done it for the sake of explaining. I have actually divided it, right? And by dividing it, it comes like this, and remainder is 0. So remainder when fx is divided by x plus 1 is, so here the remainder is 0. I have found it by actually dividing it, but you do not have to do this. Simple way, remainder when fx is divided by x plus 1 is f minus 1. So f minus 1 is, and we by putting the value of x is equal to minus 1, we get it as 0. So remainder is 0. So when find remainder when fx is divided by x minus 1 by 2, so we have to put the value of, so what will be the remainder? fa. So the a is equal to 1 by 2 here, right? So r has to be of degree 0. I've just made the proof of it, but that is not required. You just can put that f 1 by 2 is the remainder. And let us do it by actually dividing. So for your exercise, you can do it, actually divide it as well. We should try to solve the problem in different ways and try to understand the concept behind that. Beyond formula, there is proof. Beyond formula, there is concept. And to understand the concept, you have to do it with the first principle. So mathematics is all about first principle. If you have to remember formula, you will never understand mathematics. So formula is important to quickly solve the problem, but to understand the problem, you have to do it by the first principle. You have to actually divide. You have to do the hard work of finding out how it is happening. So that is the way to read maths. That is, I am telling repeatedly. For any time, anything you to understand, you need to start with the first principle. Remember when fx is divided by x. Remember when fx is divided by x. So here x minus a, value of a is 0. So when fx is divided by x, so that value will be, when you put the x value of x as 0, so that will be f0. So remainder will be 1. By actual division also we got remainder as 1. Remainder when fx is divided by x plus pi, same way here a is minus pi. Remember when fx is divided by 5 plus 2x, right? So you can take 5 by 2 as common, and you can write x plus, sorry, 2 by 5 as common. Then you can write sorry, we will take 2 as common. If take 2 outside, then it will be 2 times x plus 5 by 2, 2 plus x by 5 by 2. So the x plus 5 by 2 is the form of x minus a. Here a is minus 5 by 2. So why we are finding the zero of this polynomial? Why? Because if the divisor becomes zero, then the in the expression we are left only with the remainder. You have to remember the formula. Dividend equals to divisor into quotient plus remainder. So that is why we are finding the zeros of this 2x plus 5. So f minus 5 by 2 is the remainder, right? So when we say divided with 5 plus 2x, we are saying divided with 2 times of x plus 5 by 2. So when x equals to minus 5 by 2, this expression will be 0. So that is why we need to find out the 0 of this. So remainder will be f minus 5 by 2. Find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. So what it will be? If it will remainder is f a. And if it is if px is fx is divided by x minus a, the remainder is f a. That is by remainder theorem. Check whether 7 plus 3x is a factor of 3x cube plus 7x. So 7 plus 3x, you have to write 7 plus 3x as 3 multiplied by x plus 7 by 3. So you have to divide the polynomial 3x cube plus 7x by this expression. So if this is the factor of this polynomial, then for x equals to minus 7 by 3, this has to be 0. But we find that this is not 0, so 7 plus 3x is not a factor of 3x cube plus 7x. For exercise, we are doing it by actually dividing it. Here also we have got the remainder is not 0. So this is not a factor. And now comes the factor theorem. Factor theorem. If px is a polynomial of degree n greater than equals to 1 and a is any real number, then first x minus a is a factor of px if pa equals to 0 and pa equals to 0 if x minus a is a factor of px. So there are two expressions, that is x minus a is a factor of px is pa equals to 0. In another word, it is saying x minus a is a factor of px if remainder is 0. Right? So if remainder is 0, so definitely it will be a factor. And if remainder is 0, then x minus a is a factor of px. So the second expression is the same thing. Is telling things in another way. So first expression, x minus a is a factor if remainder is 0. In another way, if remainder is 0, then x minus a will be a factor. Right? So pa is the remainder when we divide a polynomial with x minus a, that we know with the remainder theorem, and that is the proof of factor theorem. So let us do it. By the remainder theorem, we know px equals to x minus a into qx. Qx is the quotient fact function. right? X minus a is the divisor, qx is the quotient, and pa is the remainder. Here we are not writing r. Instead of r, we are directly writing pa, because pa is the remainder when we divide px with x minus a. So this needs to be understood clearly. So pa is the remainder when we divide a polynomial with x minus a. That is comes from remainder theorem. If pa equals to 0, then px equals to x minus a into qx, which shows that x minus a is a factor of px, right? Because if pa is 0, then this terms has gone to be 0. So what we are left with only x minus a into qx. So clearly x minus a is a factor of px. The second expression, since x minus a is a factor of px, the remainder has to be 0, right? So since x minus a is a factor of px, we can write px as x minus a into gx, some another function that is gx, right? So x minus a into qx, that is quotient, plus pa, that is remainder, and that is equals to x minus a into gx, right? And for x equals to a, the first expression becomes a minus a plus pa, and this also becomes 0, right? So for x equals to a, pa is equals to 0. So if x minus a is a factor of px, then pa is equals to 0. Both side is the same expression px. We need to understand this, that both side is px. And to find out pa, we have to change x to a, right? So this is pa, and we find that a minus a is 0. Here a minus a is also 0. So what we are left with, pa is equals to 0. So if x minus a is a factor, then pa is 0. So that is factor theorem. So I will repeat it once more. If px is a polynomial of degree n greater than 1 and a is any real number, then x minus a is a factor of px if pa is 0. X minus a is a factor of px if pa is 0. pa, and second is, if pa is 0, pa is 0 if x minus a is a factor of px. Example, examine whether x plus 2 is a factor of this polynomial. So we have to see if x plus 2 is a factor of this polynomial. So if this will be a factor of this polynomial when p minus 2 is equals to 0. So when x equals to minus 2, this expression is become 0, then x plus 2 will be factor, but because remainder is 0. So 0 of x plus 2 is minus 2, so let p minus 2 is 0. So by factor theorem, x plus 2 is a factor of px. Likewise, x plus 2 for sx, there is a function, let us suppose the function is sx is 2x plus 4, and for x equals to minus 2, this is 0, so x plus 2 is a factor of 2x plus 4 as well by factor theorem. So we have come to the exercise. So first do it yourself, pause the video, do the exercise and come back again. Determine which of the following polynomials has x plus 1 as a factor. So to find that which polynomial has x plus 1 as a factor, you have to put x equals to minus 1 and see if it is 0. So p minus 1, it is equals to 0. So by so remainder after dividing px with x plus 1 is 0. So by factor theorem, x plus 1 is a factor of px. So likewise here also you have to try to find out p minus 1 in all these expressions. Also remember, all this exercise has been done by me, and there can be some error somewhere. You may find some error. If you find some error, then report it in the comment box. Use factor theorem to determine whether gx is a factor of px in each of the following cases. So there is two polynomial px and gx. So we have to find out whether gx is a factor of px. So what is gx? X plus 1. So we have two polynomial. One of them is x plus 1 of degree 1, right? X plus 1. So to find that whether gx is a factor of px, what we have to do? We have to check whether p minus 1 is 0 or not. If it is 0, then it will be a factor. Likewise, this is gx is x plus 2. So here, what is the value of a? X minus a. So value of a is minus 2 here. So we have to check minus 2, p minus 2. So the remainder is not 0. So x plus 2 is not a factor. Likewise, for this expression, find the value of k if x minus 1 is a factor of px in each of the following cases. Find the value of k if x minus 1 is a factor of px. So if x minus 1 is a factor of px, then p1 will be 0, right? So we will put x equals to 1 and find the value of k. So x minus 1 is a factor of this polynomial, so p1 will be 0. Since x minus 1 is a factor of px, therefore p1 is 0 by factor theorem. Factorize 12x square minus 7x plus 1. We will factorize by splitting the middle term, right? So factorizing by splitting the middle term will be easier here, and you must have read it in earlier classes how to factorize it. So to factorize, you need to find out two terms a and b, so that a multiplied by b is 12 times 1 and b, that is 12, and a plus b has to be minus 7. So we have found that those two numbers 3 and 4, and we have split the minus 7x as 3x and 4x, and like this we have found this. So if this is a polynomial, so if we can factorize this polynomial as 4x minus 1 and 3x minus 1, so it means that 12x square minus 7x plus 1 is equals to 4x minus 1 into 3x minus 1. So what will be the zeros of this polynomial? So for what value of x this will be 0? So either 4x minus 1 is 0 or 3x minus 1 is 0, because 0 multiplied by any other number is 0. So one of them has to be 0. So if 4x minus 1 is 0, then x is equal to 1 by 4. And when 3x minus 1 is 0, so x is equal to 1 by 3. So for the value of 1 x equals to 1 by 4 or x equals to 1 by 3, this polynomial is 0. So these are also called the roots of the polynomial. So one of the purpose of factorizing a polynomial is to find the roots of the polynomial as well. So if you can factorize this, factorize 2x square plus 7x plus 3. So we have to find a and b such that a multiplied by b is 2 in times 3 and a plus b is 7. So 6. So 6 plus 1 is 7. So we can factorize it like this: 2x square plus 6x plus x plus 3, x plus 3 into 2x plus 1. Try it yourself. If help is required, you can see the solution. So main thing is we have to multiply the two numbers and we have to split the middle term so that addition is same and multiplication is minus 36. So we have found that number 9x minus 4x. So 9 fours are 36. That is minus 36. We have to make it minus 36. So 9x minus 4x is 5x. Likewise, for this, we have to split the middle term so that the sum is minus 1 and product is minus 12. So the sum is minus 1 and product is minus 12. So this is hit and trial method. This has no rule. This is hit and trial only. You have to split the middle term by hit and trial. You have to find out those two numbers. And if you have factorized this, it means that for x equals to minus 1, for x equals to minus 1, this polynomial is 0. Because if you put x equals to minus 1 here, it becomes 0 multiplied by 3x minus 4. So 0 multiplied by any number is 0. So for x equals to minus 1, this polynomial has to be 0. Or for x equals to 4 by 3, this has to be 0. So p minus 1 is 0 and p 4 by 3 is 0. So we have factorized it with splitting the middle term method. We can factorize it by finding the roots of this equation as well, like finding the zeros of the polynomial. If we can find the zeros of the polynomial, then also we can write this equation. Like if we know that for x equals to minus 1, this is 0, right? So for or x equals to 4 by 3, this is 0. So how we will write that? Okay, let us factorize x cube minus 2x square minus x plus 2. So one of the one of the way by which you can factorize a polynomial is finding the roots of the polynomial. If we can find the zeros of this polynomial, then that if a is the root of this polynomial, if x equals to a, this is pa is 0, then x minus a is a factor of px. That is coming from factor theorem. So that is the factor theorem. So we will find the roots of this polynomial. Px equals to x cube minus 2x square minus x plus 2. So p0 is not 0. p1 is 0. So 1 is root of this polynomial. So therefore x minus 1 is a factor of px by factor theorem. So we can write px is equal to x minus 1 into gx, some quotient. For some quotient gx, if you divide this polynomial by x minus 1, you get some quotient, that is gx, and we will find the gx by actually dividing it. We are dividing this polynomial by x minus 1. So after dividing, we get the quotient as x square minus x minus 2 and remainder as 0. So we can write the polynomial as divisor into quotient plus remainder, that is 0. Okay, and we will further factorize the second term. We will check whether we can factorize it by splitting the middle term. So we could factorize it. So the roots of this polynomial is 1, 2 and minus 1. But we have to only factorize it. That was the question. So this has been factorized. So to factorize it, you can go use the factor theorem. For any x, if you can find that for any x this is 0, so that x minus a will be factor. For if x is equal to a, this polynomial is 0, so x minus a is a factor of the polynomial from factor theorem. So this is the use of factor theorem. So we are factorizing x cube minus 3x square minus 9x minus 5. So we will first find the roots of this polynomial. We will see For 0, x equals to 0, this is not 0. For x equals to 1, this is not 0. For x equals to minus 1, this is 0. So if x equals to minus 1, p minus 1 is 0, it means x plus 1 is a factor of this polynomial. So since x at x equals to minus 1, px is 0, therefore x plus 1 is a factor of px. So if we have found the one of the factors, so we will divide it and found the quotient of it. So by actually dividing, we get this. You should learn how to divide it, like x cube. So first we have to make the x cube 0. So x multiplied by x square becomes x cube. So x cube plus x square, then you have to subtract it, so the sign will change. So 3x square minus 3x square minus x square, that is minus 4x square. Next when you divide, you have to make it 0. So you have to multiply with minus 4x. Minus 4x multiplied with x is minus 4x square. So minus 4x square into minus 4x. So when you subtract, the sign will change. So minus 9x plus 4x is minus 5x, minus 5. And we have to make minus 5x 0. So to make minus 5x 0, you will multiply by minus 5. So when you multiply with minus 5, both of term goes to 0, cancel each other. So you get the remainder as 0. So this can be written as, the polynomial can be written as x plus 1 into quotient, like divisor into quotient plus remainder, that is 0. And you have to factorize it, the second term. So split the second term, so that multiplication is minus 5, 1 into minus 5, that is mine. So minus 5 plus minus 5x plus x is minus 4x. So we have got this. X plus 1 into x minus 5 into x plus 1, right? Factorize this. So in these polynomials, we are using the factor theorem to find out. We are trying our luck. We are going with the trial and error method to find if there is, for some x, if it is 0 or not. So this is just hit and trial. There is no rule as such. So we will see for x equals to minus 1, this is becoming 0. It is not necessary for all, you will find some x for which it will be 0. So in that case, if you are not able to find some x, so one of the case might be that this polynomial can't be factorized. Right, for any x, this is not 0. If for any x, it is not 0. If for certain you can prove that for any x, it is not 0. In that case, there will be no roots of this polynomial. And in that case, for any x, if it is not 0, it means this polynomial can't be factorized as well. Therefore, x plus 1 is a factor of px, because for p equals to x equals to minus 1, this is 0. So this is p minus 1 is 0. So by factor theorem, x plus 1 is a factor of px. You have to understand factor theorem that is being used. So we are actually dividing this. To actually divide, you have to make x cube first, x cube 0. So x square you have to multiply. When it becomes 12x square, you have to make 12x square 0. So that you have to multiply with 12x. Then comes 20x, then you have to make 20x 0. So you have to multiply with 20. So that 20 becomes 0. And we find that the remainder itself is 0. So this is divisor into quotient plus remainder. So we are able to factorize it. We have to factorize this. So in all these cases, you can see that for sum of y, it is becoming 0, right? Because it is in the problem book, so there is high chances that it will be 0 for some value of y. So you have to just try to find out for which value of y it is 0. It is simple. It is coming for y equals to 1, it is becoming 0. So Therefore y is a factor of it. There is another way you can factorize this. You can try to find out the other way. This other way is you take y square common in the first term. Okay, so there is another way we can factorize it. We take y square common, then it will become 2y plus 1 minus 2y plus 1 equals to 2y plus
Here's
1
what I found.
into y square minus 1, and this is y square minus 1 is 2y plus 1 into y plus 1 into y minus 1. So this is much simpler way than finding the zeros of the polynomial, but to understand factor theorem, this needs to be done. So by factor theorem, if you need, you can factorize it with the factor theorem also. So for y equals to 1, the p1 is 0, so y minus 1 is a factor, and you actually divide it with y minus 1, then you find that for 2y square plus 3y plus 1, this is 0. So the polynomial can be written in this form, and further it can be factorized by factorizing the middle term. Algebraic identities. So from earlier classes we know this, that x plus y whole square is equals to x square plus 2xy plus y square, and x minus y whole square is x square minus 2xy plus y square. So how will you know x plus y whole square is x square plus 2xy plus y square? We can try to actually multiply this. You do not have to remember everything first in the first glance. First you have to try to find out how this is coming, the proof of the formula. So if you know the proof of the formula, you can very easily and remember the formula. X square plus xy plus xy plus y square. So xy 2xy, x square plus 2xy plus y square. So likewise, you can derive all the formula. Always in algebra, you just try to do it by first principle. You multiply it by yourself, then you will understand it. X minus y is to whole square is x square minus 2xy plus y square. X square minus y square is equal to x minus y into x plus y. Right? You can just expand it and you know how it is coming. Right? You just expand it, you will know how it is coming. X plus a into x plus b is x square plus a plus b into x plus ab. So this is also the distributive law. By distributive law, when you multiply these two, you can find out how it is coming. x plus y plus z whole square is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Try to find out yourself. It is very good exercise. Multiply this and see whether it is coming or not. X plus y whole cube. So first you have to find out x plus y whole square, then you have to multiply x plus y with that. So you get x cube plus y cube plus 3xy square plus 3x square y. Like x minus y whole cube is x cube minus 3x square y plus 3xy square minus y cube. And x cube plus y cube plus z cube minus 3xyz is equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So this is a very important formula. Like all other formula you might be remembering, this might be new for you. You have to expand the right hand side and see what is coming.